Hello, everyone. Welcome to the course C. This is our last Astro Professor video, and we have Professor Rolf Dolford here to answer your questions. This week, we have three questions. I will read these questions, and Professor Dolford will answer them one by one. All right, then let's start. The first one is about the flakiness index. So one student asked how this flakiness index or the particle shape of the stones can influence the long-term performance of the ballast, or maybe some other influential factors. Could you please, Rolf, comment on this?
Yes, first of all, many thanks for all the questions. I really enjoy to making this kind of videos. There's real questions, real people with real problems asking me for help. Great. That's what we like to do this ask the professor directly, and I think that helps a lot to understand the course and the content even better. Now we're on the maintenance part of the life cycle, so I really enjoyed this part. It's also a little my background, so I like this a lot to give answers. About the shape of the ballast, I think that's really important. This when I listen carefully, it's also about, okay, is it only the poor geometry, what is not correct of the ballast? Is that the only reason why you have problems in degradation, etc.? Now, you also need a load of a train, of course, and also how the load will be transferring from the point wheel rail contact into the construction to the soil. And when that's not correct, then you also get problems in the ballast, of course, because you get higher pressure, high peaks, whatever, vibrations, and that will also not help. Especially vibrations will not help, because then you get this, so normally you have a very sharp edges on the particles, and when it is moving with a high frequency and dynamics, then it will be more a round shape. And then when it is round, it can roll, and roll means not steady. And then you don't get this trapezium shape, so then you don't get the full use of the ballast to the soil. That means there's also a question in this question about, okay, how can we reuse or how can we make it better? What you see in practice is that you use the sharp new stones more or less on top, so in between the sleepers, and then when you go deeper and deeper, you can say, okay, maybe these marbles, the old ones, can be in lower down, because then it's not moving that much, because it is pre-stressed by the construction and the load itself. So when you like to be cheap and say, okay, can I reuse this not nice sharp edges anymore of the ballast, put them lower and the fresh ones on top, because there the need for sharing the load is more and more needed than in below. But the shape is really important, that you don't have this point contact going directly to the sleeper, and just the surface of the sleeper will only press vertically downstairs. Now you like to have a trapezium, so more area to share the load, and then you have no problems at the embankment. And that's the reason we need ballast. So think about it.
Prof? And the second question is about the wear, which is addressed in the week 3. And the students ask, is there any sign to identify the wear is transforming from the media stage to the later stage? And how can this wear be detected or managed?
Yeah, I think it's really a very important and also safety question, because when you have cracks in your wheel or in your steel construction, then how can you sleep well in the night when you have no idea what is the status of this crack? So you need non-destructive sensors like ultrasound or eddy current to detect what is the stage and the quality of your crack or your asset in this regard. Therefore, we have these non-destructive sensors. We use them very worldwide, and everyone is using this. But that's more about how to control safety. But I think when I listen carefully to this question, you'd like to know, how can I predict? How can I know where it will fail? So not waiting till it failed, like a fire brigade. No, you like to know, okay, I'm not on the edge. I can still survive for a few months, but you like to have a guarantee that you can survive for a few months. And therefore you need different sensors, not only non-destructive or geometry, but then you need really like exobox acceleration accelerometers, or we need laser Doppler thermometry. So then you need also the dynamic stiffness. because then you really know the system approach, the system as a construction, how it works, and also where are the weak points in this area. So to be honest, we do this already for more than 10 years, and we know exactly when we drive over with the normal operational speed, we know exactly what are the missing characteristics in the construction, broken spring, broken clip, broken whatever, and also what is the condition of the ballast. We can also measure this when we drive over. And then you can make, as a real asset manager, a prediction. Okay, when do I need maintenance actions? Can I delay it or do nothing? There's also a possibility because I do a renewal, say within a few months, and I can survive these few months. So you can use this in a very relaxed way. No fire brigade anymore. You can predict, and that gives more rest and also nice for the operational guys to know, okay, when is this corridor out for maintenance? And that will be the future in my view, because we have a lack of personnel, lack of money. So we have to do maintenance just on the spot, on the real time, just in time. Safety first.
Rolf. Then
Yes.
we move to our last question. That's
Okay.
about AI use. This data science and machine learning are addressing our week 4 content, and the student ask, in practice, do we already widely use these technologies in the Dutch railway or in the European railway?
Yeah, it's a good question. I think it's still in development and it's also going strong. In our group, for example, we have multiple people with multiple background, but 2 FTE in our group of, say, 30 people, we have a background in AI. And that's not because it's hip, it's nice and shiny, it's also very useful. And give me an example why we think this is useful. When we use our measurement train with these special devices like ABA, LDV, and measurements to predict the status of our assets, we also like to know, okay, how can we predict this? But what is prediction? Because when I drive over, for example, on the squat, and you hit with the wheel only half of the shape of the squat, could be because different shape, the different wheel maintenance status. Then what is it? Is it, you can say it's a half squat? No, it's a squat or not. That should be the question. And how to manage this to get a higher hit rate at the end. Therefore, machine learning can help to say, okay, the shape looks like a squat. It looks like a copy paste of another squat. So that could help us to have a higher hit rate because of machine learning. And that's a tool to help the operator. In my view, it's not that far that the tool can say, yes, this is a full squat. I think that's too far yet. So I think it could help to give a higher hit rate by question mark issues or cases. But to say, okay, I make a decision, this is a squat, so full speed, yes, it is. I think we are not there yet, but that will come soon. We have more powerful calculations, bigger computers. So it's just a matter of time, but that will still wait for a few years. But therefore, the development of AI would be very important to do this kind of helping the operator in the good direction. So it helps, yes. And also using very, very much. Yeah.
Rolf, since this is the last video for this course, do you have some final comments to the students?
Yeah, I really enjoyed. I see it was a very active people, also with problems on their own country. It also helps with different countries, different cultures, different background, why you make choices. And that's also good for the other students to understand, hey, why they do a different decision in another country, because there's a different culture, because of background history, maybe also how much budget you have. No problem. I'm not verdicting people who say no, this is wrong or this is good. I think we learn from each other, and that's the good point. I see this activity very well. Nice questions. So I really encourage you to go on for the capstone. So please enroll yourselves, and then we see a real problem with all the knowledge you already learned in the last phase of this 4 stages of online learning. And hopefully you have your own problem, bring it to the capstone, and then we meet again. So I look forward for that. Many thanks.
Just now, in Professor Dolfo's answer, he addressed this new technology LDV, that is a laser Doppler vibrometer, that is a newly developed method to detect the track detections and to monitoring the track conditions. And this is fully developed by our TU Delft team. And with this technology, last week we participated a demonstration in the DG track event, which is held in Amersfoort, the Netherlands. And in the following video, I will show you how this device looks like and what kind of applications can be used.
Great.
Yeah.
Now, good luck with that.
Yeah. Thanks. Hello everyone, welcome back to the course. The course team today is visiting one of the important events in the Dutch railway that is called the DG track. That is about the demonstration of the digitalization methods for the railway track applications. And we as a TU Delft team, we also have one demonstration, and I would like to show with you. Here, this is our newly developed solution using the laser Doppler vibrometer to detect the vibration signals on the structure. Here we have one LDV device, and this has a laser targeted on the structure surface, and when there's any vibration of the surface, then it can be detected from the signal here. I can show you, for instance, now I just hit this rail piece a bit, then we see some oscillation signals, and if I hammer the rail, and we can also see a different signal with different frequencies. When analyzing the frequency components and amplitudes, then we can detect the structural properties and also to diagnose the degradation of the structures. For instance, in this structure, when the train is moving, and then we can see the vibration of the bridge, the track, the train, and also the embankment, the different components based on this laser Doppler vibrometer signals. And I will also show you now the signal is almost flat, but if we make the train to move, then we see some oscillation of the bridge, and when the train passes, there's a huge oscillation. And if there's any detection of the structure, it can be effectively diagnosed by the train. And so we have already implemented this laser Doppler vibrometer to our CTO management tree, and put it on board and targeting on the railway track, and it can detect a different type of defects of the track infrastructure. This is a timeline of the innovation of this technology. We started the concept from about 2010, and now we already got this prototype. And this is a new European project I'm for real, and we will also apply our this new method to achieve the goal of this project. And there are also some other demonstrations regarding the digitalization solutions provided by, for instance, Microsoft here and as well, and also ProRail and NS at those sites. Thank you.